Dear learners, I welcome you all to this online learning platform. In today's lecture, we will see our Module 5, Lecture 15, that is Fire Triangle and Various Sources of Fire. These are the various contents which we are going to discuss today. First one, Introduction to Fire Triangle, Introduction to Fire Tetrahedron, Oxygen as a component, heat as a component, and fuel as a component. Interaction to all the components, sources of ignition, common fuel sources, human activities at ignition sources, natural sources of ignition, electrical sources of ignition, prevention and safety measures, various case studies, and at last conclusion. So let us see first introduction of a fire triangle. The fire triangle is a fundamental concept in a fire science and safety that helps us to understand the conditions necessary for a fire to occur and sustain itself. It is depicted as an equilateral triangle with each of its three concerned representatives, a key component essential for combustion. These components are oxygen, heat, and fuel. A fire cannot exist or continue to burn if any one of these components is removed or altered. These components of fire triangles are oxygens. Let us see about oxygen. Oxygen is a vital element for any combustion. It's present in the air around us and it's necessary for most material to burn. Burning a fire, oxygen molecules combines with the fuel molecules releasing energy in the form of heat and light. The oxygen concentration in the surrounding atmosphere determines whether or not a material will ignite or how quickly a fire will spread. Second one is heat. Heat is a energy required to raise the temperature of the substances to its ignition point. Heat is responsible for igniting the combustion process by breaking a chemical bonds within a fuel molecules. This creates volatile gases that can react with the oxygens. Once a fire has started, heat generated by the combustion process helps sustain a fire by providing the energy needed to maintain a chemical reaction. Third one is fuel. Fuel refers to any material that can undergo combustion. It can be a solid, liquid, or gas. Different fuels have a different ignition points and burn at a different rates. The type of amount of a fuel present influence the intensity, duration, and behavior of a fire. Let us see what is fire tetrahedron. The term fire tetrahedron is often used to describe the four elements that are required for a fire to occur or sustain itself. These elements are represented as a four sides of a fire tetrahedron, which is a three-dimensional geometric shape with four triangular faces. The four elements of the fire tetrahedron are fuel. Let us see what this says. So, this is the material that can burn and release energy in form of heat. It can be a solid, liquid, or gas substances that provides the necessary carbon and hydrogen atoms for combustion. Second one is oxygen, means fire requires oxygen from the air and support the combustion process. Oxygen reacts with the fuel to release energy in the form of heat and light. Third one is heat. Heat is the energy needed to initiate a combustion process. It raises the temperature of a fuel to its ignition point, at which the chemical reaction between the fuel and oxygen starts. And fourth one is chain reactions. In some models, a fourth element called the chain reaction is included. This refers to the self-sustaining chemical reaction that occur once the fire has started. As the fuel and oxygen react, they release heat which further raises the temperature and accelerate the combination process. Alternation or removal of the components. It means the fire triangle concept is a crucial for fire safety and prevention. Removing oxygen by smothering a fire with a fire extinguisher or covering it with a non-flammable material can extinguish this fire. Cooling the fuel or lowering the temperature can remove the heat component, also leading to fire extinction. Third one is starvation. Starvation means removing or isolating the fuel can prevent a fire from starting or continuing. Understanding the fire triangles help us design effective fire prevention strategies, develop safer handling practices for flammable materials, and respond appropriately in case of fire emergency. Next one is oxygen as a component. Importance of oxygen for combustion. Oxygen is a critical component for combustion, which is the chemical reaction between a fuel and oxygen can release energy in the form of heat and light. The presence of oxygen is essential for initiating and sustaining the process of burning. Without oxygen, combustion cannot occur. Here's why oxygen is crucial. First, oxidation means combination is essentially a rapid oxidation process. Oxygen molecules from the surroundings air interact with the fuel's molecules, breaking their chemical bonds and releasing energy. Second one is release of energy. It means the energy releasing during a combustion is a result of the rearrangement of atoms within the fuel molecules. This energy appears as a heat and light. And the third one is chemical reaction. It means the chemical reaction between the fuel and oxygen is a exothermic, means it releases energy in the form of heat. This heat further sustains the combination process. Next one we will see role of oxygen in supporting combustion. It means oxygen plays several key roles in the process of combustion, like first one, supporting the reaction. Yes, oxygen acts as an oxidizer in the oxidation reduction reaction that continues combustion. It accepts electrons from the fuel, facilitating the breakdown of molecules, bonds and release of energy. Second one is generating heat. As the oxidation reaction process, energy is released in the form of heat. This heat is what raises the temperature of the fuel to its ignition point, initiating the combination process. Third one is sustaining the fire. Means once the fire has started, oxygen continues to consumed as a fuel burns. The ongoing supply of oxygen allows a fire to sustain itself by maintaining a chemical chain reaction necessary for combustion. Next one is oxygen concentration level for ignition and combustion. It means the concentration of oxygen in a surrounding atmosphere is crucial for ignition and combustion. The minimum amount of oxygen required for a combustion depends on the type of fuel and its specific characteristics. First one is ignition point. Let us see what this point say. Means the ignition point is the temperature at which a fuel starts to produce enough flammable gases to sustain a combustion. This temperature is influenced by the fuel's composition, volatility, and heat of vaporization. Adequate oxygen must be present for these procedures to occur. Second one is lower flammable limit or LFL. It means this is a minimum concentration of oxygen in the air below which a fuel air mixture is too rich to burn. If there is not enough oxygen, a mixture is too fuel heavy to support combustion. Third one is upper flammable limit or UFL. It means this is a maximum concentration of a fuel air mixture above which too lean to burn. In this case, there is too much oxygen for a available fuel. Heats as a component. Let us see the heat's role in the fire triangle. Heat is a fundamental component of a fire triangle representing the energy required to initiate or sustain the combustion process. It plays a pivotal role in breaking down the chemical bonds within the fuel molecules, enabling the release of flammable gases and can react with the oxygen. Here's how heat function is a construct for a fire triangle. First one is breaking bonds. It means heat energy is needed to break down initial molecule bond within a fuel. This process results in the formation of highly flammable gases that can mix with the oxygen. Second one is activation energy. Every chemical reaction requires a certain amount of energy to get started, known as a activation energy. Heat provides this energy, helping the reaction between the fuel and oxygen to overcome the activation barrier and proceed rapidly. Third one is self-sustaining reaction. Means once the combustion process has begun, the heat generated by the reaction is sufficient to continue breaking down fuel molecules, releasing more energy and maintaining a chemical reaction. Next one is heat sources that can initiate combustion. It means there are various sources of heat that can initiate combustion leading to the fires. First one is open flames. Means naked flames like those from candles, matches, lighters or gases stoves can provide the necessary heat to start a fire by raising the temperature of nearby flammable material. Second one is spark. Means friction, electrical sparks or impacts can generate heat sufficient to ignite combustion material. Third one source is electrical faults. It means overloaded circuits, short circuits or faulty wiring can generate heat and sparks, potentially leading to the fire. And fourth one is chemical reaction. Chemical reaction means certain chemical reactions are exothermic, releasing heat as a byproduct. If this reaction occur in a presence of flammable materials, they can initiate fires. Fourth one is heat accumulation. It means even without an obvious ignition sources, heat can accumulate in a confined spaces, causing spontaneous ignition in certain materials. Temperature required for ignition is our next point. Let us see what this point says. The temperature required for ignition dependent on the specific material and its properties. First one is ignition temperature. It means this is a minimum temperature at which a material start to self-ignite and produce flammable gases. Different materials have a different ignition temperature. Second one is flash point. The flash point is the lowest temperature at which material emits in a vapor to form a ignitable mixture with the air. It's a crucial factor in a fire safety assessment. Third one is fire point. Means fire point is the temperature at which a material continues to burn after ignition. It's higher than a flash point and indicates sustained combustion. Next one is safety and heat. Means understanding heat sources and temperature requirements for ignition is crucial for fire prevention and safety. Next one is safe handling. It means knowing the potential heat sources helps individuals handle flammable materials and equipment safely. Next one is electrical safety. Means awareness of electrical faults and proper wiring practices reduce the risk of electrical fires. Next one is preventing overheating. Regular maintenance and proper ventilation help to prevent heat built up in enclosed surfaces. Next one is fire risk assessment. Means knowledge of ignition temperature, flash point and flash point aids in assessing the fire risk associated with the various materials. By grasping the significance of heat as a component of a fire triangle, individuals can take proactively steps to minimize fire hazards, apply preventive measures and respond effectively in case of a fire emergency. Fifth one is fuel as a component. It means definition of a fuel is a context of a fire. It means let us see the definition of a fuel in a context of fire. In this context of fire, fuel refers to any substances that can undergo combustion, resulting in the release of energy in the form of heat and light. Fuel provides the material necessary for the fire triangle to be complete and alongside oxygen and heat. Understanding the characteristics of types of fuels is crucial for assessing fire hazards, preventing fires, and effectively responding to the fire emergencies. Let us see the different types of fuel that may be a flammable materials. These are the various types of fuel encompassing solids, liquids and gases. These materials vary in their ignition properties, flammability and combustion behavior. Some common examples of flammable materials include flammable liquids. Let us see what this flammable liquid says. These liquids have a low flash point and can easily vaporize to form a ignitable mixture with the air. Examples include gasoline, alcohol, paint, thinner and oils. Second one is flammable gases. Gaseous substances that can form an explosive mixture with the air fall under this category. Example includes propane, methane, hydrogen and butane. Third one is combustible solids. These solid materials have a potential to burn under certain conditions. Example includes wood, paper, textiles, plastics and certain metals in finely divided forms. Fourth one is pyrophoric materials. It means these materials can ignite spontaneously when exposed to the air due to their extreme reactivity. For example, certain metal powder or alkali metals. Fifth one is spontaneously combustion materials. It means these materials can catch fire without an external heat sources due to internal chemical reaction. Example includes oily rags, hay and certain chemicals. Importance of the fuel type in determining fire behavior. Let us see what this point say. The type of fuel plays a significant role in determining the behavior and characteristics of a fire. First one is flammability. It means different fuel have a various flammability levels. Some materials ignite easily while others require highly temperature or sustained heat exposure. Second one is burn rate. The rate at which a fuel burns depends on its composition, structure, and the energy contains. Flammable liquids and gases typically burn faster than the solid materials. Third one is heat output. The energy released during the combustion varies based on the type of fuel. This impact of intensity of the fuel and the potential for spreading to the nearby material. Fourth one is emission of harmful substances. The combustion of certain materials can release toxic gases, smoke, and particulates that pose health hazard to the humans and the environment. Fifth one is fire spread. The behavior of the fire is influenced by the fuel's arrangement, distribution, proximity to the other flammable materials. Different fuels can result in various fire patterns and spread rates. Let us see various safety and fuel types. Understanding the types of fuel is crucial for fire safety and prevention. First one is storage and handling. A proper storage and handling practices for flammable materials are essential to prevent accidental ignition. Second one is firefighting strategies. Firefighting need to be aware of type of a fuel involved to choose the appropriate extinguishing agents and techniques. Third one is fire risk assessment. Identifying the types of fuel in a given environment help assess the potential and fire hazards and design the preventive measure. By comprehending the properties and the behavior of the different fuel types, individuals can implement effective fire safety measures and reduce the fire risk and also respond the appropriate to fire incidents. Next one is interaction of the all components. How these three components interact to the sustain of a fire. Let us see what this point says. The fire triangle illustrates how the three components oxygen, heat and fuel interact to sustain a fire. Here is how they work together. First one is initiation. Heat is applied to the fuel, raising its temperature to the ignition point. This breaks down the molecular bonds within a fuel, create volatile gases. Second one is combustion. These gases mix with the surrounding oxygen in the air. When the mixture reaches a certain temperature, it ignites. The chemical reaction between the fuel and oxygen release energy in the form of heat and light. Third one is sustained reaction. As long as there is a continuous supply of oxygen, fuel and heat, a chemical reaction continues. The heat generated from the combustion process provides the activation energy needed to break down more fuel molecules and maintain the reaction. Breakdown of a fire's progression if one component is removed. Let us see what this point say if one of the component of this fire triangle is removed. The fire triangle concept emphasizes the interdependence of its component. If any one of the component is removed or significantly altered, the fire cannot be sustained. Here's what happened when each component is taken out. First one is oxygen removal. Means if the oxygen is removed by smothering the fire or creating an oxygen deficient environment, the combustion process stops and the fire is extinguished because there is no oxidizer to support this reaction. Second one is heat removal. By cooling the fuel between its ignition temperature, the heat components is eliminated. The fire is extinguished as there is no longer enough energy to maintain the combustion reaction. And the third one is fuel removal. By removing the fuel sources, such as by removing the flammable material away, stop the supply of combustion materials. Without fuel, the fire cannot continue to burn, and this process is also known as starvation. Understanding this interaction helps to illustrate the delicate balance required for a fire to exist. The fire triangle provides the foundational understanding of the fire behavior and forms the basic for effective fire prevention and firefighting strategies. Next, seventh point is source of ignition. Let us see what this point says. External heat sources that can initiate a fire. It means fires can be ignited by various external heat sources. These sources provide the initial energy needed to raise the temperature of a fuel to its ignition point. Understanding these sources is crucial for fire safety and prevention. First one is open flame. It means naked flame from sources like candle, matches, lighters, gas stoves and fireplaces can provide the required heat to ignite flammable materials. These flames can come into the direct contact with the combustible substances and initiate fires. Second one is sparks. Sparks are tiny hot particles that can result from friction, impact and collision. These sparks can ignite nearby combustible materials. Sources of sparks include metal on metal friction, grinding and striking. Third one is electrical fault. Means electrical fault can generate heat and sparks due to short circuits, overloaded heats and damaged wiring. If these sparks come into contact with the flammable material, this can lead to a fire. Let us see some example of sources of ignitions. First one is cigarette butts. It means improperly discarded cigarette butts can remain hot enough to ignite dry lips, paper or other combustible materials. Second one is welding and cutting operation. The intense heat generated during the welding or cutting metals can produce spark that lead to a fires if they come into contact with a flammable materials. Third one is cooking equipments. Kitchen appliances such as stoves, ovens and toasters can generate a high heat if left unattended, or if food debris accumulates, they can be a source of a fire. Electrical appliances. Manufacturing and improperly used electrical appliances like space heaters, iron, curling irons can generate heat and sparks, posing a fire risk. Fifth one is lightning. Lightning strikes during thunderstorms can generate extremely high temperature, potentially igniting fires in forest, building and other areas. Next one is hot surfaces. Equipment or machinery that generates heat during the operation, such as energies, motors and exhaust system, can cause nearby material to ignite. Let us see various sources of common fuel sources like gasoline and alcohol. Flammable liquids are substances that can easily evaporate to form a flammable vapors that can ignite when exposed to an ignition sources. Here are some examples of a flammable liquids. First one is gasoline. Gasoline is a common fuel used in a vehicle and machinery. It is a highly volatile and can produce a vapor that ignites easily, making it a significant fire hazard. Second one is alcohol. Third one is petroleum based liquids. Dear learners, we have explored today your knowledge in fire triangle, fire tetrahedron and various sources of fire. And in next class we will see the further case studies and conclusion of this topic. Dear learners, thank you all for listening me with patience. I hope you explored your knowledge in the fire triangle and various sources of fire. In next lecture, we will continue this topic and also we will see various classes of fire and extinguishing methods. Thank you.